Hello, my name is Justin Sulik. I'm a postdoc in the Cognition, Values and Behavior Lab at Ludwig Maximilian University of Munich. And today I'd like to tell you about our study, the contingency illusion bias as a potential driver of science denial. By science denial, I mean beliefs such as the following. For instance, that anthropogenic climate change isn't real, that vaccines do more harm than good, that the coronavirus is a hoax or no stronger than the flu, or that face masks can suffocate you. Now, these beliefs are not simply a matter of disagreeing with the scientific consensus. There are other aspects to them. For instance, a resistance to disconfirming scientific evidence, distrust of scientists, or even a misunderstanding the nature of science. And that sets this kind of false belief apart from an example like believing that Lagos is the capital of Nigeria, which is not true. And if someone tells you what the capital really is, one's reaction to this experience is probably very different from the reaction of a science denier being told that climate change is real. And it's important to understand this kind of phenomenon because it often has harmful outcomes, such as inaction in the face of potentially devastating climate change, or indeed in the face of a global pandemic. There are two main approaches to explaining science denial. One focuses on social factors, such as religious identity or political ideology, and the beliefs that go along with being part of one group. The other approach tends to focus on cognitive factors, such as a deficit in analytic or reflective thinking, or an over-reliance on an intuitive cognitive style. Now, I think this is not enough to explain science denial. I don't think it's wrong. I think it's entirely accurate. I just think something else is needed. So, for instance, an intuitive style is a dispositional factor. It makes you more likely to tend to do certain things, but that doesn't explain exactly how people end up at a false belief like evolution is false. What I think is missing is more understanding of what we could call the process of inquiry. You could call this lay science, science among non-experts. And it's just the various steps that go into updating your beliefs. So for instance, noticing something surprising, generating an hypothesis that could explain away that phenomenon, gathering data, testing your hypotheses, and updating your beliefs accordingly. And it's these factors that I would like to focus on more. Now, the biases involved in that kind of process are studied in related phenomena, other kinds of misbeliefs, such as conspiracy theorizing, belief in the paranormal, or delusions. These kinds of biases include jumping to conclusions, deciding without enough evidence, a bias against disconfirmatory evidence, being resistant to disconfirming evidence, a preference for teleological explanations, or what's often called the causal illusion bias. I'm going to be calling it the contingency illusion bias because it usually involves causation, but it doesn't have to. At its core, this is just inferring a meaningful relationship where there isn't one. And actually, it refers to a cluster of similar seeming biases, such as apophenia, which is seeing meaning in what's actually random noise. It's called often a type 1 error bias, illusory pattern perception, or the illusion of causality. And our first question is, does it make sense to talk about a contingency illusion bias? More specifically, do these terms and their associated measurements actually tap the same underlying cognitive factor? If so, does this contingency illusion bias predict science denial? Does it mediate more dispositional effects like intuitive cognitive style? And does it still predict unique variance in science denial, even accounting for social factors like religion or political ideology? We recruited 415 participants via Mechanical Turk and excluded 51 of them for failing attention checks to ensure that our data is of high quality. We gave them 4 science-style questions, for instance, about evolution, climate change, GMOs, vaccines. These were hidden among 12 more general scientific knowledge questions, such as, does the Earth go around the sun or the other way around, so that it wouldn't be so obvious we were studying science denial. We gave them 4 cognitive reflection test items, which measure their reliance on intuitive cognitive style. We asked about their religion and political ideology and gave them 4 contingency illusion tasks that I will describe for you. The first is called the coin toss task. We generated 100 random tosses of a virtual coin and divided those into sequences of 10 tosses. And for each sequence of 10 tosses, we asked the participant, does this look random or determined, and what coin side do they think will come next? They know, because we've told them, that it's a random coin, and yet people are still quite happy to believe that there is a meaningful pattern here and that they have a better than 50-50 chance of predicting the next toss. Next is the mousetrap game. Here the player controls a mouse and they just need to navigate around this grid towards the cheese there and to try and get the cheese within a certain time limit. There they got the cheese. There is in fact a rule that determines whether they get stuck in the trap like now or whether they get the cheese. And that rule is simple. You just have to wait more than about 4 seconds, like now. And if you do that, you'll get the cheese. But in fact, people develop superstitions based on accidents. So maybe someone did a U-turn, which slowed them down, but then they believe that you have to do a U-turn to get the cheese, which is demonstrably false. They can test this because they have 10 chances to do this. Next, we gave them some spurious correlations. For instance, that chocolate consumption is correlated with the number of Nobel Prize winners. And we asked them, do they think it's causal, if there's a third factor that explains this, or if it's a random coincidence, which is the true answer. And finally, a contingency detection task. Here they are playing as a doctor trying to cure a disease called Lindsay disease, which gives you a green face. And they're testing a potential cure called Batitrim, a medicine. And they need to decide for each participant whether to administer Batitrim or not. And they're told that sometimes they should and sometimes they shouldn't. So each time they see a patient, they decide whether to administer the medicine, they observe the outcome, and then move on to the next patient. In fact, there's straightforwardly a 0.7 probability of the patient being cured no matter what they do. So there is no effect of the medicine, and yet people typically end up believing that it is efficacious. So our questions were, do these measures load on a common latent factor, and does that factor predict science denial? And the answer is yes. Here are the 4 contingency illusion tasks loading on a latent factor in a structural equation model, and the 4 science denial questions loading on a latent science denial factor. This model has good fit, and contingency illusion is a significant predictor of science denial. I'm slightly hesitant though, because you may notice that the strongest contingency loading, which is 0.45, these are standardized loadings for ease of comparison, is as strong as the weakest science denial loading. So these loadings are not very high, and there are a number of reasons for this. It could be that the tasks are noisy, that there is unexplained variation, and I will return to this question later. The next is, does this factor mediate the effect of cognitive style? Again, the answer is yes. Analytic style does significantly predict science denial. However, when you include this contingency illusion factor as a mediator, the effect of analytic style drops out. And does it still explain unique variance accounting for religion and ideology? Well, yes. For instance, if you regress science denial on these 2 factors, both are significant predictors. The political ideology is the stronger predictor, but the contingency illusion is still there. So overall, there is evidence for an underlying contingency illusion bias, but the loadings were not very strong. I think this is unsurprising given how different these tasks are and how open-ended some of them are. For instance, the mouse task allows you a lot of scope to play around. So this does bring noise into the mix, but I think these gamified tasks are very useful if we want to engage the public in this kind of research. And I think it's very important that we try and move out the lab and start doing that more than we have been currently. Next, this bias mediates the effect of intuitive cognitive style. I'm not taking that strongly enough to say that it's definitely the causal illusion, contingency illusion bias that does that. I'm taking this as illustrating the more general point, which is that these dispositional variables, like an intuitive cognitive style, has an effect on science denial via particular mechanisms in the belief formation process. And I think these mechanisms and how they relate on one end to dispositional variables, on the other end, science denial, needs more study. And finally, this bias does add something useful and complementary to approaches based on social factors. In future work, this is part of a broader project where we are studying other aspects of inquiry, things like hypothesis generation, data gathering, hypothesis testing, and decisions in a social context. And finally, I think it is definitely worth seeing how this kind of bias extends to the current pandemic. So thank you, and I look forward to your questions either here or via email.